In this segment, we're going to practice finding inverse trig values. One of the first things you need to recognize is that the answer to all of these problems is an angle. Normally, when we're working with sine, we input an angle, we output a value between 0 and 1. When you're working with inverse trig, the output is an angle. And I think it's wise to write it like this, right? That switch the x and the y and go back to sine, not inverse sine, but sine, and recognize that this is saying what angle has a sine of radical 3 over 2. And the other thing we have to keep in mind is that the answer for sine and tangent has to be between negative pi over 2 and pi over 2. Whereas the answer for cosine, because of the restrictions we placed on the domain so that our function would be 1 to 1 before we took the inverse, cosine got restricted from 0 to pi, tangent and sine got restricted from negative pi over 2 to pi over 2. Okay, so again, I encourage you not to just watch me do the work, but try these on your own before checking your answers with the answers that I'm going to give. For this first example, so we should know what angle has a sine of radical 3 over 2. That's 60 degrees. Okay, 60 degrees is pi over 3. Okay, when we want negative radical 3 over 2, we don't get to the fourth quadrant by going like this, right? We don't look at a 300-degree angle. We look at the coterminal angle, which is found by going like this, okay? Because what I first drew in blue would not be an angle in between negative 90 and positive 90. So we need this angle right here. The reference angle, of course, is 60 degrees, right? Pi over 3. So our final answer then would just be negative pi over 3. All right. I think this one's pretty easy, right? Cosine of what angle is radical 3 over 2? Well, if it were 60 degrees when it's sine, that makes it 30 degrees for cosine, okay? And this is a first quadrant angle, so nothing tricky about this. So this would be pi over 6, or 30 degrees. Now, when we go to find the inverse cosine of negative 3 radical 3 over 2, cosine is negative in the second quadrant, okay? So we have this 30-degree reference angle, but we have to come over here, right? We're in the second quadrant. So what angle then goes from here to here? Okay, we've got this 30-degree reference angle. So that would be 150 degrees. 180 minus 30. So 150 degrees. Now we want to be in radians. So if I set up a proportion, 180 degrees is to pi radians, as 150 degrees is to x radians. Right? You could solve that proportion, or you might just know I multiply it by, if you solve this proportion, it'd be the same result. I multiply it by pi over 180. Right? That's what that results in. So let's see, cross out the zeros, divide both by 3, and that is 5 pi over 6 for this answer. This is probably the hardest. Like, I think if I gave you a quiz on this, this would probably be the hardest one to get right. All right, so what angle has a sine of pi over 2? Okay, we could use our unit circle, or we could draw the sine curve. Okay, but yeah, wait, this is why This is why I'm stumbling here. This should actually be, I'm sorry, this should actually say sine of 1. What angle has a sine of 1? Well, I think I just gave it away, right? This is asking then find the angle whose sine is 1. Okay, so that was a typo. That should have been a 1 right off the bat. It doesn't make any sense to try to input an angle into inverse trig. And so this, of course, would be pi over 2. And then what angle has a tangent of 1? Right? Well, since tangent is sine over cosine, and sine and cosine have the same value at 45 degrees, and 45 degrees is pi over 4, then the answer here would be pi over 4.